to use tools, those tools being a browser and half a brain. Essentially, we're going to show you and kind of walk through some of the basics, if you want to. Oh, you did go to the next slide. We're going to talk about general brute forcing of web applications. And when we talk about brute forcing, the traditional brute forcing sense is entering usernames and passwords into an application, operating system, some sort of software package, which is tedious. What we're going to be talking about is essentially making that job a lot easier for an attacker, because now he doesn't need to know a username and password. He can attack the state mechanism of that application. So essentially we're going to be talking about that, show you some fun examples, talk about essentially what 3 orders of audiences can do: users, software vendors, and developers of websites, people who have to actually buy the, I'm going to use a nice word, the software products that are out there today. So just to go over some basics, we all know you log into a web application. Web applications protect sensitive data. There's been a push in the last couple of years to put everything on the web for competitive pressures. So you log into a web application, and obviously you don't have to keep on entering your username and password after each click. And obviously that's because of convenience, and it's because a sense of state is somewhat maintained for your session. So let's talk about just a traditional brute force. I go to an eBay login and I try guest, 123, 123, password, someone's birthday. We're all familiar with this. No need to spend a lot of time on it. So what the heck is a session ID? Well, because HTTP is a stateless protocol, it means each web request is not connected to the next. There's no way intrinsically in this protocol for it to know that me logging in and clicking on something is going to be my web request. It doesn't have my name on it. Essentially what we have to do is we have to create a system where each of those web requests has a sense of ownership. And just to talk about a decent example, if Michael is actually going to a bar, imagine a system where you show the bouncer your credit card. Bouncer picks a number, a unique number, stamps it on his hand, and he can then go to the bartender, tell her that number, and she'll charge his tab for any drinks he wants to buy. So when he goes to the bar and orders his favorite drink, which is the Shirley Temple, he orders it, goes to his tab. I'm making that up. Is it? Oh. Essentially, the 2 things that can happen if I can guess that number on his hand. You want to go to the our session replay. Actually, go to the next slide. I'm sorry. Next slide. Our session replay and session hijacking. So if I were to walk up and impersonate him and actually order him 10 drinks on his tab, that would be somewhat a session replay. If I were to mimic his exact movements in his ordering that drink. If I were to actually dress like him, which isn't hard to do, and actually replace him, that would be somewhat of session hijacking. A better way of explaining it is, if you're actually on Amazon.com, and again, if Michael's on Amazon.com, he's ordering Kama Sutra for Dummies. I see him making that request. I mimic the request and I order him 10 copies instead. Hijacking would be me actually becoming him and owning his session and actually sending that copy to me, because it's an interesting book, I'm sure. You actually go back 2 slides. So the idea is you're exchanging a username and password for a string, a session ID. It's usually stored in a cookie. It's sent across each web request. It's not necessarily well known that the same security controls and strengths that are applied to the username and password should be applied to that session ID. Again, if someone were able to read that stamp on Michael's hand, it's almost as if they had his credit card. So in theory, you should have the same security controls. Do we have that in practice? No, or else this is going to be a very short presentation. So
David didn't actually share all of his bad jokes with me while we were practicing, so I apologize ahead of time. I would have stopped him. David mentioned session IDs and cookies, and when we think of session IDs, we generally associate it with cookies, but that isn't the only place that they can be stored. A session ID is just a variable that's passed between the browser and the web server. So it can be stored anywhere that variables are passed in that fashion. Besides cookies, other locations where it could be stored would be hidden fields in an HTML form, for example, or directly within the URL itself in a GET request. And we'll see some examples of that when we move on in the presentation. As far as how the session ID is actually created, that's not generally something that the individual who's writing the code for the web page has to worry a great deal about. That's generally handled by the web server or the application server. To give a concrete example, those of you who may be familiar with ASP pages, you know there's a session object. You can create variables with that, and those variables are going to be automatically associated with a user logging into your application. It's very handy because there's little effort required on your part. It's very easy to do. The downside is that you're somewhat at the mercy of the algorithms and such that are used to create that session variable. If they're strong, good. If they're not, you may or may not be kind of stuck. Just a quick refresher on cookies, because this will become important as we go along in the presentation. There's effectively two types. You have your persistent and your session cookies, or non-persistent. Basically, it's when they expire. If you have a non-persistent or session cookie, that is only going to be there while the user is logged in. When they log off or close that browser, it disappears. It's only in main memory. Persistent cookie is actually stored on your hard drive, and I'm sure you all know where that's stored. It's dependent upon the browser that you're using in the operating system. But the difference is when we use session IDs and cookies, we generally want that session cookie, something that's not going to stick around. The persistent cookie, that's generally used for things like the Remember Me option on web pages. You have that page that you like to use as your home page, and you got your news and everything all fancied up, and you don't want to log in each time. So that's generally the situation where a persistent cookie would be used. Just the basic layout of what a cookie is. We've numbered the fields, so I'll just refer to them that way. The first field, number 1, that's where that cookie came from, the web server that initially gave it to you. In this case, it's Red Hat's web server. Second field, Boolean variable, which just determines if that is the only server that can retrieve that cookie, or if it can go to any other server within that domain. Third field, that is the path to specific pages on that server. Again, it just allows you greater granularity to limit where that cookie is going to go to. 4, another Boolean variable, in this case determining whether or not a secure connection needs to be established before that cookie will be passed. So it has to be a SSL connection before the cookie will be sent. 5, that's your expiry. If you don't have an expiry, that's when you have a session cookie that's only going to stay in main memory. If you do give it an expiry, that number is in Unix time, meaning number of seconds since January 1970. And then 6 and 7, that's your payload. That's the data of the cookie in a name and value fashion. So in this case, the name of that variable or that session ID is Apache, and then in number 7, that's the actual session ID itself. In this case, it appears to be some sort of concatenation of the IP address that you have and a numeric string. These are just, let me try our free laser pointer, see if it'll actually work. No, not at all. That's what you get for what you pay for. These are just examples, just showing you that same format. You'll see they all fall into those 7 fields that we pointed out. Some of the developers are a little more creative. Star Wars has the Wookiee cookie. Others not so creative. Amazon just calls theirs a session ID. But in all cases, that's what the cookie's being used for. I mentioned that cookies aren't the only place that session IDs can be stored, and not the only way that they can be passed. These are all examples of session IDs embedded directly within the URL and sent using the GET method. Obviously, it's not going to be as secure for various reasons. If you're not using SSL, it's being passed out in the clear. The end user can actually see that in their browser. They have the option of changing some values. But for various reasons, you may want to use that, and we'll look at some examples of why that may or may not be a good idea.
Additionally, if proxy server on your end stores this information, and someone breaks into that proxy server, they have full access to your authentication information.
That's a good point. Even if you have SSL, if it's going through a proxy server, it may show up in the logs. And then I mentioned that there was, yet another way that you can be passing session variables back and forth, and one would be a hidden field within an HTML form. We all know that HTML forms, that's designed to allow users to interactively send variables to that web server. You could use a hidden field to be passing that. The red item, the first red item is session ID. And just before we get too far into this, I just want to kind of provide some scope. Obviously, we're talking about one very specific security issue within a very big issue of developing web applications. And it's important to keep it in that context. We all know that there's no point in focusing very narrowly. You have to look at all aspects that can affect it. I can use the most secure algorithm in the world and come up with this great pseudo-random number that nobody's ever going to guess the next one in the sequence. But maybe I have poor policies, and when I designed that server, I decided to use persistent cookies, so it's stored locally on the browser itself or on the web server over time. And there's poor physical, logical security on those boxes. Somebody could walk in and steal it anyway. So it's just important to keep everything in perspective. This will just walk through an example of, first of all, the session ID being within the URL and how someone may be able to brute force that. This website, 123greetings.com, you're all familiar with this concept. They create greeting cards. You can log in, you create a greeting card for your better half, email it to them, and they get an email message. Go to the next one. And what they are effectively receiving is a URL with a session ID embedded in it, and it allows them to just click on that link and go directly to their personal greeting card. The authentication is built into the session ID, so they don't have to provide a username and password. And in this case, if you look at the session ID is at the end of that URL, it looks like a pretty long, hard to guess number. I think it's about 16 characters. So in theory, if you were going to brute force that, 10 to the power 16, I don't even know the name of a number that big, but this is the greeting card. I think if your co-presenter sends you this greeting card, it might be time to get a new presenter. Maybe let's go back to the slides. At least I know what's coming up. So if you look at that, when we first looked at it, it looked like it was very random because, 16 characters long, it's got numbers, it's got letters, it looks pretty good. But then if we want to actually determine if it is truly random, we can generate a number of the IDs in succession, and that's going to reveal a great deal more about it. And if we look at those, we start to see that maybe it's not very random at all. In fact, the first 3 letters there, or numbers and letters, 83 every time. Looks like it's some kind of constant, it's always the same. And then the next one, again, they're all the same numbers. And if you look a little bit closer, in this case, we generated these cookies on July 25th at 12:21. So it's time-based, so that's obviously something that and so you can figure out. So we're really down to like 4 or 5 characters at the end. So we're talking about, 10,000 combinations. That's a lot easier to brute force than 10 to the power 16. And then, how do you go about brute forcing that? Well, you could manually type into your URL 10,000 times, but that's obviously not a very efficient way. So you can use a tool. In this case, we've put one together, and David will walk through how it works.
Sure. Just to let you know, yesterday was National Friendship Day, so. I'm going to actually cheat a little so we don't have to wait here for several hours while we do brute force this. I'm just going to go over this tool very simply. In doing a lot of web application testing, there's a lot of tedious work in collecting these session IDs, and a lot of the ways you can find out if these session IDs are predictable or brute forceable in nature is just by looking at it. There aren't a lot of great tools, AI, mystic algorithms that you can plug these session IDs into, and sometimes you just have to look at a lot of them generated in sequence. So this is just a Visual Basic program. It's open source. We'll give you a link to the source code later. It's actually included on your conference CD. I'm just going to choose Google. And they actually use session IDs, I believe, for tracking, not necessarily for authentication, but at least show you how this tool works. So I'm just going to get 5 cookies, port 80. Usually it's a lot faster, but we'll blame it on all the ARP spoofing. Essentially what normally happens is you get 5 session IDs loaded in sequence. Essentially you can see most of these values are somewhat random, at least random to the naked eye. We'll go back to that redhat.com uh-oh. redhat.com example. You can also include the time in the output just to better possibly lead to some more insights into how the session ID is being generated. So as you look at the generation of a sequence of these, obviously, well, once we get more than one, obviously there's a lot of this session ID that doesn't have any entropy at all. Obviously it's based on our IP address. And we're going to talk about good and bad session ID generation methods. Obviously generating it with a session ID IP address appended to it is not exactly a unique session ID, and it is reverse engineerable. The middle part is essentially out of the scope of this presentation. It's basically basic authentication, brute forcing. We just put it in there because a lot of the code that we developed for all 3 of these led into this type of attack as well. Here's the power of the brute forcing. And before we were writing Perl scripts to do a lot of this. We just got tired of modifying the script each time. So I'm going to paste in the URL of our greeting card. And what we're going to do is we're just going to brute force the last 2 digits. Essentially, it's kind of obscure, the regular expression you have to use, but I provided a decent guide here. Essentially, you put the number you want to brute force in brackets, the beginning number, comma, and then the range. You can do numbers, letters, lowercase, uppercase, or a combination of the above. So let's just do numbers, and we'll start it at 70. The actual greeting card is at 82. So essentially, this will keep the entire URL the same except for those 2 digits, and we'll just click brute force it. So there it goes, and once it gets to 82, this is version 1, so I might add a scroll bar in version 2. So, oh, there's a scroll bar. I'm going to just scroll down. Obviously, when it got to 82, it spits out the actual brute forced greeting card that it found. Now, sometimes when you're brute forcing URL sites or sites that use cookies, what it's doing right now, if you look at the radio box right here, or radio button, we're just looking for non-404 headers as a signal that it succeeded. Some sites use custom error messages such as these aren't the droids you're looking for, go away, mind your own business. So you have to actually enter in what a successful response would look like, some text such as welcome or hello or something like that. So that's this tool in a nutshell. It just simplifies a lot of the attacks we're going to be talking about. In the paper, we also wrote on these topics on the conference CD as well. You'll find a lot of the Perl scripts that were used to exploit these types of attacks early on. So why is this bad? Well, obviously, it can result in a replay attack or your session being hijacked. These are really easy to exploit attacks. You just saw me exploit one. It doesn't really require a lot of skill. You just have to know what to type in and some sort of structure to a session ID. In a typical login scenario, you might have 4 or 5 tries before an account gets locked out. Same thing with a PIN number, with an ATM card. Similar sorts of circumstances on everything you can think of that requires a username and a password. Unfortunately, with session IDs, there's no real way to detect a failed login. If someone keeps on grinding through URL after URL, cookie after cookie, there's no way for most web application servers to detect this. Additionally, a lot of the intrusion detection systems out there do nothing to detect this. We're starting to see, we're starting to hear about commercial products that may try to detect these types of attacks. Additionally, really the only logging of these types of attacks are in your access logs and your error logs, and most people probably don't audit those logs very regularly. In fact, if they do aggregated statistics with a tool like Web Trends, it would probably just show a large, on Tuesday there was a large hit from China. Someone from China was trying to brute force your site, and that really wouldn't tell you much. You'd just say, oh wow, our marketing is really working in China. Before you grill me on the last point, it should actually read server-side SSL does nothing to protect against these attacks. What that means is essentially most types of SSL on the internet are server-side that don't require a client certificate that's then verified and validated and generated by some sort of PKI. A lot of people, and I'm sure you know them, a lot of clients, potential clients, think that because they have SSL, they're protected from most web application attacks. Indeed, this just encrypts all the attacks so that their intrusion detection system can't detect them. We're going to talk about client-side certificates later, but essentially, if you take some measures to authenticate, further authenticate your user based on entity authentication, that browser certificate, essentially what will happen is that request will get redirected to a failed login or failed authentication request. Again, if you have credentials, this is a totally different issue. We picked this out just to show that web application security is getting more attention, and as it should. I think this was really the first sample of some type of attack like this making the news. Essentially, Verizon wireless customers would go to their website, log in, they'd have a really great authentication system. Username and password had to be just so mauve and 6 to 8 characters, and couldn't choose something that was based on a dictionary word, etc. Unfortunately, once they logged in, they got redirected to this URL. Unfortunately, if you see the session ID located in red, incrementing or decrementing that session ID allowed you to look at other customers' information. Oops. This is actually good and bad in a way. It means that everyone knew about this. This was actually the bug track posting. Everyone knew about this probably before they were able to fix it. In the positive sense, this type of press is probably going to make vendors and websites fix these problems a little faster. Now, if you want to go to this is my personal website. I was trying to use it for anonymity, but too many links were adjusted with me, so I kind of threw that out the window and used it for demonstration purposes. Securitypimps.com. I host it at register.com. If you're actually going to play it on your laptop, warning, there's a kind of a bass riff that pipes in, so you might want to turn your volume off just to see that I'm not full of it. Essentially, register.com allows you to log in, change your DNS settings using this application called the Domain Manager. You enter your DNS settings, click apply, and it's done. One day, I actually wanted to change my DNS settings. I forgot my password. So all you have to do, actually, could you go back to the last slide? All you have to do is enter the domain name in that you forgot your password to, and then it sends it to the administrative contact. Okay, that's fine. What happens is you get sent an email, or the administrative contact, Pimp Daddy, which is me. You go to the next one. This is the email. It has a URL in there that leads you to a page, essentially, which just lets you change your password without entering the old one in. There's the URL. Great, lots of digits at the end. Wonderful. So I was curious. What I did is I pressed back and submit, and et cetera. And I got these IDs. As you can see, if I were to just brute force these URLs based on that long number at the end, it would probably take a long time. But as I noticed, there's probably a lot less entropy in these session IDs that register.com would likely have me think. So essentially, what was once a 12-digit brute forcing attempt, I think that's 12, is now a 5-digit attempt. So essentially, these IDs are active for 3 days. If I can cause someone's domain to have this link active, and I can hope that they don't visit this page first. I believe I did the math. If you did 1 request per second, and of course someone's going to bust me on it because we have mathematicians in the crowd, I think you could do it in over 50% of the time in that 3-day window. Consequently, a lot of these vulnerabilities, we disclosed them, I think, about a year ago. As you can see, some sites haven't done anything to fix these problems. Register.com actually did change their forgot password scheme, so please don't try and hijack this, because actually, I think a few days ago, I started getting a bunch of emails from the forgotten password system. Just one more, actually, you can just go on to the next example. I was going to say, this exploit is a lot easier if you actually have an account at register.com. So, for instance, if I'm trying to hijack blackhat.com, it's hosted at register.com. And I can use my website to see what the next session ID and sequence is. So essentially, I have the forgotten password for Black Hat, the forgotten password screen for myself, hit it at near the same time, and I'll probably get 2 session IDs that are really close to each other, which will let me probably cut down that brute forcing field a couple more digits.
These next couple of examples, again, with the session ID being passed directly in the URL. In this case, though, there is no randomization of the session ID, and we'll take a look at that and sort of discuss some of the consequences of that. This first site, DFilm, I don't know if you guys have ever used it. It's actually a really cool site. It's basically has sort of pre-built Flash movie scripts, and you can take different pieces and put it together and make your own movie, and then, like with the greeting card, send it to your friend and have narrative in there and stuff like that. So it's kind of like an animated greeting card. It's pretty cool. Again, you go in, you create your movie, and then you say who you want that sent off to. They ultimately receive an email message with the URL, and embedded within that URL is the session ID. And the purpose of that, again, is to have that authentication sort of embedded right in there so that you don't have to log in. You just click on the link and you're there. I don't know if we're going to get it up or not. Let's just go back to the slide. But anyway, if you look at the actual session ID, and we're going again, just sort of refreshing the. Okay, we'll get the movie. But the point is that that session ID is purely a sequential number. There's actually no attempt in this situation to make it difficult to guess in any way. And so it's clear in this case that the developers didn't develop the security in. They didn't intend to develop the security into it. This was just purely a means of being able to send a user to a unique web page. But I think it's important to remember that when you're developing these things, even if you didn't intend for security to be in there, that's really not the important thing. You shouldn't be developing applications to your specifications. You should be developing them to your ultimate end user specifications. If they think that there's security in there, and they find out later that there is none, and that anybody can see their stuff, they may not be too impressed by that. So, you know, develop to the end user, not to yourself. This is obviously something that David made. And again, we noted that it's purely sequential. So the person who made their film after David made his film, you just keep incrementing or decrementing that number, and you're going to go see somebody else's film. So let's just go back to the slide. Are we going to get this one?
I don't know. It's stuck at 80. Teases us.
All right. Let's. We got lots of time. All right. Bet you didn't think you were going to get no little porn today, but you were wrong. But anyway, so I mean, again, the point is that, you know, they didn't design the security in there, but if somebody, you know, is using this to send a message, and, you know, it might not be a DFilm site, it might be something purely different, but they think that this is a safe message, they're not going to be too impressed by that. This is a second example, same thing. The session ID within the URL no randomization, so it's fairly clear that they weren't building this as a security mechanism. This Sendomatic, it's, again, one of those things you guys have seen 100 times. There's probably a million different sites that do it. If you're planning a party, you can use this site to go on and send out invitations, and people can respond back, and then you know who's going to show up at your party. So again, you go onto the site, you set up your party, and it sends you the URL with the session ID embedded in the message. In this case, this isn't the URL that's sent to the people that you invited to the party. This is actually sent to you to administer the party. So there is a little bit of a security issue there, because obviously if, again, you can just increment your number, decrement your number, and you're into somebody else's planning of a party. So invite all your friends to their party, have a big house wrecker, and it's, you know, have a great time.
So this is actually someone else's party, girls' night out. It was one after ours. It would actually have been a good idea if we had faked it, but it was too good to be true. Fortunately, it wasn't in the DC area. What we would have loved to have done is take pictures and shown you that we crashed this party. But
that's making the theoretical practical.
So going back to my Security Pimps website, it's actually hosted on freeservers.com. Freeservers is just basically a site that you can get a free domain, 20 megabytes, and essentially there's ad space associated with the site, so that anyone who hits your site, and you have just some basic choices like testing 123 or I'm sorry, itgo.com, freeservers.com. I actually transferred my domain over there, so I still got 20 megabytes free. What you do is you log in, and to manage content, you log in with a domain, and you enter a password. So I just developed testing123.itgo.com for demonstration purposes. You log in, and it's like any other content management system. You can, alter the site, manage your files, etc. This is a tool called Mini Browser. Essentially, it's just a browser which lets you click on tabs to see certain fields like cookies, forms, links. So essentially, we loaded that same form into Mini Browser. As you can see, we have a cookie, okay, and we have a session ID. I don't know if you can see it on the screen, but if you go to the next slide, we actually print it out there. So every time I log in, every time I logged in, I got this session ID. So just for kicks, I put it through some decoding mechanisms, just out of curiosity. One of the biggest mistakes in session ID generation is thinking you can obfuscate, try saying that about 1 a.m. tonight, obfuscate the session ID by running it through just a simple decoder or encoder like hex or base 64. So here's just a base 64 decoding site at Security Stats. And as you can see, once we decode this, the value of it is the domain, a colon, and my password. Another big no-no of session ID generation, never use personal details, username, password, birthday, dog's name, maiden name, IP address. So what we can do now, this session ID is, instead of being brute forceable, because it's kind of a long session ID, it's reverse engineerable. So what we did is we wrote a Perl exploit that essentially went through, formed these cookies by base 64 encoding the domain, colon, and then we just went through a dictionary attack. So this Perl script is included on the CD. Essentially, just for demonstration purposes, we ran it through a few of dictionary passwords, and we're able to crack through to that web page. Now, if we wanted to, we could actually brute force the entire string. I don't know how much time we have, but if you want to in your spare time, you can run the brute forcer. I'm just going to let you know that I changed that password. You can register your own domain in your spare time.
Ready?
Yeah.
All right.
Again, some sites actually use both the URL and the cookie to store the session ID. Again, we're going to stick with a screenshot of Amazon.com. No particular reason. Just want to stay short on time. And actually, what you can do is then, in the tool, instead of just putting the range in the URL, you can actually put the range in the URL and the cookie, so both will actually be incremented at the same time. Essentially, Amazon uses that session ID at the end of each URL, so it actually gets loaded in the cookie as well, just a basic example. So a lot of the examples we've been showing you are kind of a amalgam of different problems with session ID generation. There's 6 basic problems. The first 4 deal with the ability to brute force or reverse engineer a session ID. The first one is essentially just a weak algorithm. If my algorithm is the day of the week and my session ID is Thursday, and it's going to be Thursday for every user who hits my site, then obviously that's pretty weak and predictable. No form of account lockout, we talked about that before, and there aren't necessarily any good solutions for that. You could try and block an IP address, but that's not actually very useful because of the way proxying works in most ISPs. In addition, if you're behind a large company and one person might ruin it for the entire bunch as well. Short key space. I was just thinking about it, and a good example is my luggage lock. It has 4 dials on it, 0 to 9. And essentially, if you think about it, if I have a unique code every time I lock this, and only I know the code, that's great. It has a great algorithm. Only if you consider that someone could try every single combination in less than a day and open the lock, it's not a great key space. And what I can do is either add larger dials by adding more characters, or I can add about 20 more of these dials and have an insanely huge lock and get stopped at security. You can go to the next one. And a lot of users love the Remember Me option. Love the Remember Me option. Love being able to check Hotmail. Love being able to go to Amazon and do the one-click option. Unfortunately, what that does is the server remembers that session ID and lets the attacker, instead of the 3 days we saw before, have an infinite time span. So they can load their brute forcing tools, go out, go on vacation, come back a couple months later, and voila, they have the session ID. The next 2 issues are more concerned with just basic session ID security and secure retrieval and transmission. You should probably use SSL, because if there's someone sniffing the network, they could just take that session ID and load it into their browser. You should also make sure that every single cookie that has a session ID has that secure field, because what can happen is an attacker can send you an email. If it's a web-enabled email, it might have an image to the particular application he's trying to steal your cookie on. What would happen is that email would have that unsecured image that you actually draw upon. You see, or he sees, let me take a moment. I'm going to start over. An attacker can send you an email with an image embedded in it. It's drawn upon the application server that you're actually accessing. If that image is actually an unsecured application, it's an HTTP instead of an HTTPS, your current cookie session ID is actually going to be transmitted, and he can sniff that. So it's important to make sure that the cookie only gets transmitted over SSL. Additionally, just because you don't patch your browser or you have active scripting enabled just because you like it, you can still fall victim to things like cross-site scripting, just basic bugs in the browser that could enable an attacker to also steal your cookie and resulting session ID.
We just wanted to take a sec and walk through some of the tools that we often use that are helpful in, if you're auditing your own stuff or you're auditing a client's applications, to try to determine if the way that they're using session IDs is appropriate for their situation. Important thing, these are all totally free tools, for the most part open source as well, and they're great tools. Of course, first one's ours. That's the one, Sessions Auditor, that's the one that we demoed before. It's available out on the web, open source. Web Sleuth, the one below it, is actually a great tool. It does an awful lot more than this. And the Sessions Auditor component is actually embedded within that. So if you use Web Sleuth, you'll see the same thing as Sessions Auditor, but it allows you to do a number of other things. So those first 2 tools will allow you to do the brute force testing to determine how secure it is. The last 4 there are a bit different. Those are basically personal proxies. And what they're going to allow you to do is to intercept that transmission between the browser and the web server and take a look at it and even manipulate some of those variables and play around with it and determine if it is being passed in a secure manner. We mentioned mini browser before. It's just a small, simple tool, and I think David will just do a quick walkthrough of that one for you. We won't go through all the tools, but this is a really quick and dirty one, free download, great, very handy tool to have in the toolkit. So right now, he's just, he put in a URL just like you would in any browser, but what it's effectively allowing you to do is to see all those things that go on in the background that you never see when you're using just a straight browser like Internet Explorer or Netscape. You see, I realize it's small, so I'll kind of try to explain what's going on. In that dark reddy brown, actually take the highlight off. Yeah, thanks. Just that first chunk, that's the request that David sent from the browser to the server with all the header information. The second chunk, the green chunk there, that's the opposite. That's what came back from the web server, with that red line being the actual cookie that was passed and set on the browser. And then, so you can see all the messages being passed back and forth. If you look at some of the other tabs, if you want to just walk through the browse, that's obviously what you see. It's interpreting all the HTML, so you can see what the page would or should look like. Source, again, just full source. Links, the one, actually go back, just one. All your links in your page. So we mentioned that one way you can be passing a session ID is to have it embedded right in the link. This basically compartmentalizes all the source code to see what's in there. And so here's all your links. Forms, again, just pulling out all the forms that are in the page. We mentioned that you could also pass session IDs within hidden fields within a form, so that'll help you identify those. And then the cookies themselves are also split out for you. So it's just a very handy tool if you want to take a quick look at a web page. This isn't an intense audit. You're curious how this is set up. Really good tool for that. Now, what can you do as a user? Obviously, as a user, you're somewhat at the mercy of the application or the developer of the application that you're using. But there are still certain things that you can do to protect yourself. So we'll start off with those, and then we'll get into the developer and the vendor later on. Obviously, log out of your sessions when you're done. If you have those session cookies, the ones that are not persistent, they're just stored in main memory. Once you log out, that'll be taken out of there. The Remember Me option, David mentioned it already. Very handy and convenient, but like a lot of handy and convenient things, not real great for security. Protecting your cookies. I mentioned before, you can have a super algorithm that's going to make a great session ID, hard to guess, but if somebody can get to it, it doesn't matter how hard it is to guess. It's that whole concept when we had that cool diagram that we stole from somebody, I don't know who, where, you got to look at the big picture. It's not just one little sliver that you can focus on. So have the appropriate logical and physical security around your boxes. Using SSL, David already went into that. It's not going to prevent everything, but it will prevent sniffing of traffic in transit. And then patching the browser. Like, the new trend is all these cross-site scripting vulnerabilities. Every day we're seeing more and more and more of this stuff. So, as with any other tool that you use, make sure it's patched and up to date. And lastly, the point that we tried to make at the very beginning, a session ID is effectively an authentication mechanism. It shouldn't be used solely for that purpose. You want to do authentication in the traditional manner and have it traded off so that the user's not logging into the browser every single or into the web page every single time. But that's what it is. It's a security mechanism. So treat it the way you would treat a username and password that you're passing around.
So if there are any software vendors out there, what can you do for me, for us? Unfortunately, the onus of security for a lot of web application components is in the hands of the software vendor. In some cases, it's also somewhat in the hands of a website developer or someone who actually buys a lot of this software that we're getting, such as Dynamo, WebSphere, Tomcat, et cetera, whether it's free or not. So essentially, there should be some hooks to require that SSL is used for a secure connection. Obviously, you don't want your session ID going across the ethers in an HTTP instead of an HTTPS connection, as we talked about earlier. Again, ensure all cookies enable that secure field that we showed you. Provide a logout function. Some applications don't actually have one. They just assume that once the user's done, he'll close his browser, walk away, and everything will be great until the next time he logs in. And oh, amazing, he doesn't have to log in again because his session never expired. Assuming that you have some sort of system that has sensitive functions, such as checking out of a retail site, or making a stock transaction, or perhaps a banking transaction, withdrawal, deposit, re-authenticate the user. Absolutely ask him or her again for their username and password, and regenerate that session ID at the same time. You'll notice, I think Yahoo does that, even if you do the remember me option. In addition to, at critical points in your transactions, also do it in a timed interval. A lot of people have asked, well, why can't we just regenerate the token after every request? Well, unfortunately, because of the way the internet works, and it's not an ideal world, every request sent will not necessarily be received back in the same order. Additionally, you have proxy servers to deal with, and other bits of, I guess, infrastructure that's placed between the website and a web server and a proxy server. You may have other types of application servers that strip off that information. If practical, and that's a big if practical, limit successful attempts or logins from IP addresses. And this only works in a secured, controlled environment like an intranet. This can't work on the internet, obviously, because of proxying issues, because of spoofing, for a million other reasons. Again, if you have an application that only 2 people should be able to log into the administrative function, and those 2 people have to be in a SOC, then you could take some measure of certainty that that IP address of that network workstation they have to sit in will be the same every time. Again, if someone walks away from their computer, it would just be nice if there's that auto expiration feature. Same thing with time limits, only this one's based on inactivity. The last one is a little complicated, but it means that before a critical action, for instance, checking out of a shopping cart, you can only check out if the page before that actually has a nonce, some sort of, I guess, other session ID, a token of some sort, so that if someone were to do a replay attack and try and check out again, it wouldn't work because they're not coming from that secured page. Yahoo actually does this. It's called, they call it a crumb. But this is actually a useful way to prevent a lot of cross-site scripting attacks as well, prevent them from resulting in a replay attack.
You missed the booby trap.
Oh, I missed the best one. You could create actually booby trap session IDs that have, for instance, an ID that will never be generated, but if someone actually grinds through an entire list, may actually hit that. Again, once you detect someone doing this, not a lot you can do, and actually if you have suggestions, I'd love to hear them at the end. It'd be nice to know that people are doing this so that you can test your own system and make sure that it's resilient against replay and session hijacking attacks for your users. So let's talk about session ID algorithms. Basically, if we combat the first few problems, let's use a good algorithm. One-way hash, MD5, SHA1. Let's also not use inputs that are predictable, like time, like names of people, days of week. Ideally, you'd want entirely random inputs into that algorithm. An entirely random input would be something like catching radioactive particles from the atmosphere. Obviously, we don't have access to that. So good pseudo-random number generators are Yarrow, Y-A-R-R-O-W, and EGADS. Additionally, ensure that SSL or some sort of secure transmission is being used. If you want to, if it's in fact dependent on the security you want to apply to your system, you can perhaps invest in a PKI and try to give all your users certificates. This may not be feasible. again, it's kind of the business need and the business case. So for someone who actually buys the software out there, what can you do? Well, a lot of times, the vendor will actually provide hooks for creating decent session ID generated session IDs. Unfortunately, out of the box, surprise, surprise, it doesn't actually come in that state. I think ATG Dynamo version I was looking at has 3 states, and it ships on the lowest one. Essentially, just read the manual. A lot of those configuration files are just easily modified to either bump up the key space or use a different type of algorithm. Again, you might have some overhead to deal with. There is an attempt to create some commercial products. I'm not going to list them on here. If you want, I'll be glad to tell you about them after the presentation. I haven't tested them myself. That's why I don't want to list them up here. But essentially, it's another layer. It's another proxy between the application and the user. Essentially, you have some sort of black box that is actually creating another session ID that you know is secure. Say you really need to use a product like Tomcat, or say you need to use Dynamo, or say you need to use such and such because of the technology investments that your company has made. Well, you can actually build in that black box that sits between the application and the users. Can you click on the... So I'm going to plug OWASP. Michael and I are actually involved in OWASP, and through some amount of blackmail and conniving, I'm actually one of the 3 leaders of this group. 2 of the founders actually spoke earlier, Dennis Groves and Bill Pennington. What OWASP is, it's a group of volunteers trying to create a better level of awareness of web application security. I think this has just become a hot topic in the last few years, and looking out on the public resources available, there really wasn't any decent source to go for things like, what exactly is session hijacking? There were like 5 definitions by 5 different bug track posts. If you want to just click on 8. Oh yeah, I guess I could do that too. I'm just going to walk through part of it. And essentially, OWASP is a group of volunteers. It's an open source project, which means even though I wanted to use Microsoft Word to manage some of these projects, we're using XML. We're actually using most open source tools to do a lot of the testing when feasible. In general, if you look across the tabs, these are all the projects that we're currently involved in. If I encourage you to take a look at the site, drop me an email if you think you can provide value to any of these projects. I'm just going to click on the ASAC tab, Application Security Attack Components. And an effort was made to actually classify a lot of the attacks. Essentially, we talked about session replay and session hijacking. A lot of the attacks that are out there, we tried to categorize, like SQL injection, cross-site scripting. If the page actually loads, I'll be able to show you some of that. This is the blank page denial of service attack. This will actually be listed on the site. Okay, well, we may not be able to look at that right now. But in general, here we go. So on the right, you'll see general areas of attacks, input validation. That's where you'll see your cross-site scripting, SQL injection. Authentication and session management, you'll see the 2 we just talked about. So take a look. There's a lot of work yet to be done on this project. In addition, we have quite a few other projects. The guide tab is actually a secure requirements document that the draft just went out. I think we've had 100,000 downloads, but that may be inflated. I'm not sure. The testing group is a group that I'm actually pioneering right now. I actually have a couple of guys in that group here in the audience. Essentially, we're trying to create a testing methodology for you to be able to walk through and actually test for a lot of these types of attacks. There's really no decent source on the internet. The closest thing, perhaps, is the ideahamster.org open security testing methodology. It has a couple pages devoted to web security auditing, but what we're trying to do is create some sort of framework so that, at the beginning of every test, what do you do? Well, you spider the site, or you do some, even before that, you look at a lot of the resources. Do you do source code analysis? And what does that lead into? And we're trying to develop a lot of the attack trees that would then mean, okay, once you find this script, maybe that means you do some more analysis on these 2 types of scripts, which are common to this type of web server, et cetera. WebScarab is a tool we're working on. supposedly it's going to do a lot of the things that commercial scanners are going to do, open source. WebMaven is an intentionally buggy program that we're trying to develop because a lot of cross-site scripting attacks, a lot of SQL injection attacks, a lot of web application attacks are hard to visualize, and essentially you don't always have the option of performing these attacks on your own server. Sometimes your manager might not like to know that, oh great, hey, you found out about a new cross-site scripting attack, or SQL injection, great, you brought the servers down, great job, production environment. So what we're trying to do is provide a software tool that you can either load on your own system. We're probably not going to host it just because it makes sense not to have a lightning rod honeypot where everyone can throw their traffic at, like this laptop, for instance. And essentially that is going to need a lot of help. So if any of these projects interest you, drop me a line. And essentially everyone has the same say. It's a meritocracy, which means if you don't do work, we talk badly about you. So just to wrap up, and we are extremely early. We left a half hour for questions, which I know there will be not. But in a sense, it all comes down to really users don't have a lot of protection against these types of attacks. They can be aware of them, which helps. They cannot forward emails with that authentication information in the URL, etc. Developers and administrators, people who actually buy this type of software, essentially what you can do is make sure that in your architecture you're looking for these types of attacks. And a very important point that's not listed here, test your own systems. By all means, you need to know about these types of vulnerabilities for your own users. And finally, software vendors, fix your frickin' software. Some resources, the iDefense paper is located on your CD. Some other good resources as well, web application security mailing list. Go on to the next. Sorry or you're welcome for being so early. The demonstrations actually took less time than we expected. So do you have any questions, feedback, Rotten Tomatoes? Want to go upstairs and take a nap? Oh.
Couple questions. Go ahead. Yeah.
You said that you leave no tracks when you towards attack, but in the logs there will be thousands of lines saying 404 in the error log.
Yeah, absolutely.
It's the first point that the developer looks when he wants to find something because it shows a lot. The other thing is that it's probably a lot of connection from your single ID.
You bet. That's a great point.
Question.
Oh, sorry. Yeah, let me repeat the question. That was, like we had mentioned how it's tough to, there's no lockout of accounts and such, and because there aren't really mechanisms that are checking for these brute force attacks. But an excellent point was made that there are tracks, even though nothing may be preventing somebody from trying a brute force, if you go into the logs for that web server, yeah, that's going to show up. It's not a preventative control, but it's certainly a detective one that you can see that people are trying to do this to you. Other questions? I think there was one in this area. Person got scared, took off. Other questions? Right here.
Any good ways to tell when a bad seed has been provided to something like MD5?
What do you mean by bad seed?
Like a simple counter, 1, 2, 3, 4, 5. But when given to MD5, obviously you don't know whether it's starting at 0, 1 or
Sure.
0, 2.
Unfortunately, a lot of this analysis depends on more of like a gray box testing where you actually have access to the application and you can feed it inputs and you can detect the outputs. A lot of times, these types of attacks, an important thing to remember is a lot of these types of attacks, you don't need access to, bless you, you don't need access to the wire. You don't need to be a man in the middle. What's been termed in an adaptive query or a interrogative attacker, essentially someone interrogates the web server, that's their input, they get the output, and based on those types of feedback, they're able to perform these attacks. So I think what you're asking, I don't know if I'm answering it correctly to your satisfaction, you actually would probably need access to the entire system.
Other questions? feel free to also just one-on-one come up and ask us. Thank you for coming, everyone. That's
Yeah,
great.
thanks
We
a lot.
appreciate it.